Question 4. A motorcycle stunt rider travels vertically around the inside of a sphere of radius 3 meters. Find the minimum speed he must have to be able to remain in contact with the sphere when he is upside down. So again, as with all questions, a diagram usually helps. We've got my motorcycle rider. It's about as good as I can do, going round in a circle. And the question asks about what happens when he comes to the top. I'm just going to do him as a blob at the top. And the question says, find the minimum speed he must have to be able to remain in contact with the sphere when he is upside down. So what's going to be helpful to do is to think about some free body force diagrams. And to start off with, I'm going to think about the one when he's at the bottom. So down here, when he's at the bottom, his weight force is acting downwards. But he's following a circular path, and we know the resultant force has to be acting towards the center. And as such, we can say the contact force on him from the ball has to be bigger than the weight. And in fact, we could even go as far as to say the contact force minus the weight, if we're talking about their magnitudes. We've come across this problem before. This is confusing notation if you understand that these are two vector terms. In A-level physics, this means the magnitude of the contact force minus the magnitude of the weight. That has to be equal to the centripetal force. So it's the fact that the contact is bigger than the weight that means it follows a circular path. When you get to the top, things are less straightforward. So if you're going very quickly over the top, the weight force alone is not enough for you to follow this circular path. So the weight force isn't big enough to be equal to mv squared over r. So you also need a contact force to be pushing in this direction. If you slow down, you can reduce the size of this contact force. But the most you can slow down is to the point where the contact force is no longer required. So at this point, the weight should be equal to the centripetal force. The weight alone is causing this curvature. And in effect, you could take the top part of the ball out. The weight alone would allow it to go over the top. I've definitely seen videos where skateboarders have done this. They make a loop and then they put a gap in the loop and they're able to jump across the sort of upside down gap at the top. So once we've established this as an idea, answering the question is straightforward, because we can say mg, the weight of the rider, has to be equal to mv squared over r. Immediately, the masses cancel out. And we're trying to find the minimum speed. So v is equal to the square root of gr. This is the square root of 9.81 times the radius of the sphere, which is 3, which gives a value of 5.4 meters per second.